Hello math lovers, today we are going to cover theorems of circle. First there will be a theorem and then we will cover the converse of this theorem. So let's get started. So the theorem says that a line passing through the center of a circle and bisecting a chord which is not a diameter is perpendicular to the chord. So the theorem means that if we are given a circle and O is the center of the circle and there is a chord AB and we draw a line from O to AB such that it bisects AB into two parts, AC equals to CB, then this line will be perpendicular to the chord. Now remember that this line AB, that is the chord, is not a diameter. If AB is the diameter, then there is no question of line OC being perpendicular to it, because this line AB will then pass through O. So if this line will pass through O, then OC cannot be perpendicular to it. Also, if this chord AB is a diameter that passes through O, then this diameter will be made up of two radii. This means that the diameter is obviously bisected by these two radii because the diameter is equal to two radii. Having understood the theorem, our given is O is the center of the circle, AC is equals to BC, that is the line OC bisects the chord AB. Now we have to prove that the line OC is perpendicular to the chord AB. For this we have to join O to A and O to B. So now let's move to our proof, having statements backed by the reasons. Number 1, in triangle AOC and triangle BOC, OA is equal to OB. This is because they are the radii of the same circle. Then we have OC equal to OC because they are the common sides of this two triangle. And then we have AC equals to BC because this is given that OC bisects the chord AB into two parts, that is AC equals to BC. Statement 2, triangle AOC is congruent to triangle BOC. This is proved in statement 1 using side rule. Statement 3, angle ACO is equal to angle BCO. This is because corresponding angles of congruent triangles are equal. Then we have ACO plus angle BCO equals to 180 degree because these two are the adjacent angles made by OC with AB. So AB is a straight line, it has to be 180 degree. Then number 5, 2 times angle ACO is 180 degree. So substituting statement 3 in statement 4, in statement 3 it is given that angle BCO is angle ACO. So if we put ACO in this angle BCO, then 2 times ACO will becomes 180 degree. Statement 6, angle ACO equals to angle BCO equals to 90 degree. So from statement 5 and statement 3, because it is already given that 2 times angle ACO is 180 degree, so 180 divided by 2, that is angle ACO is 90 degree. And from statement 3 that angle ACO equals to angle BCO, so we can say that angle ACO equals to angle BCO equals to 90 degree. So this means that OC is perpendicular to AB. Hence proved. Now comes the converse of our theorem. So the converse says that the perpendicular from the center of a circle to a chord bisects the chord. This means that OC is perpendicular to AB, and if it is perpendicular to AB, then it bisects this chord, that is AC should be equal to BC. So what is our given? Our given is that O is the center of the circle and OC is perpendicular to AB. We have to prove that AC is equal to BC, that is OC bisects AB at C. What is our construction? So we have to join AO and we have to join BO. Now let's prove the converse of the theorem. So we have statement and then we have the reasons to support the statements. In statement 1, in triangle ACO and triangle BCO, we have angle ACO equals to angle BCO because this is already given that they are the right angles, that is OC is perpendicular to AB. Then we have OA equals to OB. This is because they are the radii of the same circle. And then we have OC equals to OC because they are the common sides of these two triangles. Statement 2, triangle ACO is congruent to triangle BCO. This is because from statement 1 we have proved it using right angle hypotenuse side rule. Statement 3, AC is equal to BC. This is because these two triangles are already proved congruent, and in congruent triangles the corresponding sides are equal. So having proved that AC equals to BC, that is OC bisects AB at C, hence our converse of theorem is proved. So friends, we have proved a theorem related to circle and its converse. So if you like this video, you can press that like button, and please do not forget to subscribe and share this video with your friends. Many such knowledgeful videos are coming soon. Thank you.